Assalamu alaikum students. Today we are going to solve the MCQs of chapter 5 liquids. First MCQ. Methylamine and hydrogen peroxide are liquid due to. So methylamine and hydrogen peroxide both contain hydrogen bonding. So it means that they are liquid because of the hydrogen bonding. Let's see their bonding. Here is the methylamine. Look, one hydrogen bonding is the bond between two electronegative element through hydrogen. Okay, it is the bond between two electronegative atom through hydrogen. So methylamine contain hydrogen bonding, that's why it's liquid. Okay, let's see the next one. Here it is hydrogen peroxide. Hydrogen peroxide also contain hydrogen bonding. Okay, like it's hydrogen, the bond between two electronegative atoms through hydrogen. It is called hydrogen bonding. Okay, it's partial positive, partial negative, and that one is partial negative. So it is the bond between the two electronegative atom through hydrogen. So we say that hydrogen bonding found between fluorine, oxygen, and nitrogen. Okay, so both of them contain hydrogen bonding, that's why they are liquid. So option C is correct. Next one. Boiling point of ammonia is greater than that of pH 3 phosphine due to. See, here is ammonia. Ammonia contains hydrogen bonding and it contains one hydrogen bond per molecule on average. Now phosphine contains dipole-dipole interaction, and we know that hydrogen bonding strength of hydrogen bond is greater than that of dipole-dipole interaction. So it means that the boiling point in ammonia will be greater than the boiling point of phosphine. So let's see the options. That boiling point of ammonia is greater than that of the phosphine due to the hydrogen bonding. Okay, ammonia contains hydrogen bonding, that's why its boiling point is greater. Next one. Liquids having hydrogen bonding are called associative liquids. So let's see how it is called associative liquid. Now those liquids having hydrogen bonding are called associative liquids because those liquids have high cohesive energy. It means that they have high cohesive power, which, for example, water has the highest power of cohesion because its molecules are smaller. So we know that what is cohesive energy or cohesive power. So cohesive power or cohesive force, it is the force between the two molecules. Okay, the force between the molecules of liquid is called cohesive power. That's why those liquids having hydrogen bonding are called associated liquids, because associated liquids means that they have cohesion, okay, between the molecules. They have cohesion between the molecules. And keep one. Now next one. Each molecule of hydrofluoric acid form only 2 hydrogen bonds, while each water molecules form 4 hydrogen bond. Water molecule form 4 hydrogen bond. Okay, next one. While performing a crucial experiment, Mr. Chemist found that an unknown liquid having dispersion force had less vapor pressure than that having hydrogen bonding. One of the possible reasons may be. Now see what is here in the MCQ. In the MCQ, they have said that there is two liquid 1 and liquid 2. Okay, two liquids. Here one contain dispersion force, means London dispersion force. Okay, London dispersion force, and the another contain hydrogen bonding. Okay, but here the vapor pressure of London dispersion force, vapor pressure is less, and here the vapor pressure is high in those liquids which contain hydrogen bond. Now what is next? They have asked that what is the reason that London dispersion for the liquid having London dispersion forces have low vapor pressure. So let's see. We know that dispersion force, London dispersion force is directly proportional to molar mass. Okay, we know that London dispersion force is directly proportional to molar mass, and here we also know that vapor pressure is inversely proportional to intermolecular force, or we can say that it is directly proportional to, inversely proportional to the strength of London dispersion force. Now, if I can also write this like vapor pressure is inversely proportional to the molar mass. Okay. Now, they have said that those having dispersion forces have low vapor pressure. So the low vapor pressure means that they have dispersion force, they have intermolecular force stronger. So the stronger intermolecular force is directly proportional to molar mass. Okay, here it is London dispersion force, so it is directly proportional to molar mass. So we can say that vapor pressure is inversely proportional to molar mass. Okay, so what is the reason? So the reason is greater molar mass of the unknown liquid. having London dispersion force. Next one. Boiling point of butane is greater than that of 2-methylpropane because. Now look, we have given the two molecule butane and 2-methylpropane. Here it's butane, okay, and butane. It's a straight chain, okay, straight chain. And it's 2-methylpropane. It's a branch chain, okay, branch. So we say that it's a relation that boiling point is inversely proportional to branching. Here, no branching is present, okay. This hydrogen bond is not considered as branching, okay. These hydrogen molecules are not considered branch, okay. This one is only considered branch, okay. So there is no branch, which means that the boiling point of this one will be greater than that one, 2-methylpropane. Now look at the options. Option A, molar mass of butane is greater than that of 2-methylpropane. No. Now see, butane is a straight chain while 2-methylpropane is branch chain compound. So option B is correct here. Boiling point is inversely proportional to branching. Next one. If all of the following liquids are at the same temperature and then liquids having least vapor pressure will be. So vapor pressure is inversely proportional to molar mass, okay. Vapor pressure is inversely proportional to molar mass. So greater the molar mass, lesser will be the vapor pressure. Now see here, heptane have greater molar mass or molar weight, okay, or molecular weight. So it means that D is the correct option. Heptane has greater molecular weight or molar mass, so its vapor pressure will be lower, okay. So option D is correct. Next one. Molar heat of sublimation is equal to. Now see this one. Now look at here. What is sublimation? Sublimation is the phenomena in which the solid is directly converted into vapors. The solid is directly converted into vapors. Now it is the combination of two phenomena. Number first, when solid is converted into liquid, it forms fusion. It is called fusion, okay. When the liquid is converted into vapors, it is called vaporization. But in sublimation here, the liquid phase is skipped. Okay, the liquid phase is skipped, so the solid is directly converted into vapors. Now, what is the molar heat of sublimation? Molar heat of the sublimation is the heat required to convert the solid into vapors. Okay, so it is called molar heat of sublimation. Now, the molar heat of sublimation will be equal to molar heat of fusion, the heat required to convert the solid into liquid. It is called molar heat of fusion, plus molar heat of vaporization, the heat required to convert the liquid into vapors. So molar heat of sublimation will be equal to the molar heat of fusion plus molar heat of vaporization. Now look at the options. C option, sum of the molar heat of vaporization and molar heat of fusion. So this one is correct, okay. All of the following statement about liquid crystals are false except. So what is the correct statement? The correct statement is here, they have orientational but weak positional order. Here option C is correct, okay. How? Let's see. See, what is orientational order? Orientational order, the group of molecules lie in the same direction. So the liquid crystals have orientational order, okay. Their molecules lie in the same direction. All of their molecules lie in the same direction, okay. Next one, what is positional order? Regular distances between the molecule. So the liquid crystals have weak positional order. Their distance between their molecule is not regular, okay. So weak positional order is weak in liquid crystal. Now look at the option C. They have orientational but weak positional order. So option C is correct, okay. It means that their molecules are oriented at the same direction. Means they have the same angle but their distances are different, okay. All of the following are liquid crystals except soap solution. Soap solution is also a liquid crystal, okay. And DNA. DNA is also a liquid crystal. How? In 1940, a scientist found that when the DNA is put in the solution of salt and water, then it forms a liquid crystal, okay. Solution of salt and water, it forms a liquid crystal, like it has the property of liquid as well as the solids, okay. Now DNA is also a liquid crystal. And cholesterol format, this is also a liquid crystal. It also forms a liquid crystal. But D here, engine oil. Engine oil is not a liquid crystal. Now all of the following are liquid crystal except. So the except one is this one. Option D is correct. Okay, option D is correct. Now next one. All of the following statement is correct for the statement. Vapor pressure of water at 0 degrees C is 5 mm of Hg pressure. Now option A is boiling point of water will be 5 degrees C at 5 mm of Hg. This one is cross. Boiling point of water will be 0 degrees C. This one is also not a confirmed statement, okay. Now, if the external pressure is 5 mm of Hg, then the water will boil at 0 degrees C. This one is correct. Now see how it is correct. Here we know that what is boiling point? Boiling point is the temperature, okay? Boiling point is the temperature at which the vapor pressure becomes equal to the external pressure, okay? The temperature at which the vapor pressure of liquid become equal to the external pressure. Now, vapor pressure of water at 0 degrees C is 5 mm of Hg. Now, the vapor pressure of water is 5 mm of Hg at 0 degrees C, okay? At 0 degrees C. Now, if the external pressure is 5 mm of Hg, the external pressure become 5 mm of Hg, then what will happen? What will happen, like at 0 degrees C, the liquid will boil, okay? At 0 degrees C, it will be the boiling point of liquid then. Now, it's the temperature at which the vapor pressure becomes equal to external pressure, okay? Vapor pressure becomes equal to external pressure, then at that temperature, the liquid will boil. Now, look, if the external pressure is 5 mm of Hg, then water will boil at 0 degrees C. It's the vapor pressure of liquid, it's the external pressure, then if they both are become equal, then 0 degrees C will be the boiling point. Next one. Drops of water and ethanol are placed on a warm stove, okay? The ethanol drops seem to evaporate more rapidly. The graph below includes the vapor pressure of ethanol and water. Which curve corresponds to ethanol? Now, they have given the water and drops of water in ethanol and placed on a warm stove. So what will happen? We know that ethanol is volatile than water. Okay, ethanol is a little volatile than water and its boiling point is lower as compared to the water. Okay, so when the temperature become a little high, then what will happen? The vapor pressure will increase. Now we know that ethanol is a volatile. It means that it will require a low temperature to evaporate as compared to water. Okay, as compared to water, it will require low temperature for evaporation. Now look here, look at the A. So it means that at low temperature the evaporation is high. Okay, the vapor pressures are high. It means that A is ethanol. Curve A is ethanol. Look at the B. The B require a high temperature. Okay, and both vapor pressures are same. A and B vapor pressures are same, but the B required high temperature and A required low temperature. So it means that A is ethanol. And look at the C and D. Their vapor pressure are very low. So it means that skip these three options and option A is ethanol. So let's see next one. Common intermolecular force for ethyl alcohol and diethyl ether are. So in ethyl alcohol we have hydrogen bonding. Okay, hydrogen bonding. And we can say that hydrogen bond is a type of dipole bond. Okay, so dipole force. Hydrogen bond is a type of dipole force. Now see how. Look at here, it's ethanol or ethyl alcohol. So here it is hydrogen bond. Okay, hydrogen bond. So we can say that here hydrogen bond is a type of dipole bond, like hydrogen bond. So we can say that hydrogen bond is a type of dipole interaction, okay, or dipole force between the fluorine, oxygen and nitrogen. Okay, it is the dipole force between fluorine, oxygen and nitrogen. So when the dipole interaction are found between fluorine, oxygen and nitrogen, then we can say that they are hydrogen bonding, and they are connected through, when they are connected through hydrogen, so we can say that they are hydrogen bond. Now look, it's oxygen and it's electronegative. Okay, and here the another oxygen, this is also electronegative, and they both are connected through hydrogen, so it is called hydrogen bond. And we can also say that it is the interaction between electropositive hydrogen and electronegative oxygen. Okay, electropositive hydrogen and electronegative oxygen. So we can say that it is the dipole movement between fluorine, oxygen, nitrogen connected through hydrogen. Okay, connected through hydrogen. So now look at the diethyl ether. It's the structure of diethyl ether. Diethyl ether contain two types of bonding. The first one is like dipole, and the second one it's like this one. Okay, the bond movement is like this one, so it means that they contain dipole. But the dipole movement of diethyl ether is very weak. Okay, here the dipole movement is very low, so sometimes we consider it as non-polar. Okay, but it has the polarity, but sometimes. So we can say that here the London dispersion forces are dominant as compared to dipole interaction. Okay, so when the when the induced dipole come closer to this ethyl ether. When the induced dipole come closer to this ethyl ether, so it induces dipole in this molecule. So we can say that London dispersion force is dominant in diethyl ether. Okay. So number first, see the option D, it's correct. That ethyl alcohol has dipole forces between oxygen, nitrogen and fluorine through hydrogen. Okay. And diethyl ether contain dispersion forces dominant. Okay. So option D is correct here. Next one. Barometer is a device used for the measurement of what? Vapor pressure of the liquid. Okay. Barometer used for measurement of vapor pressure of the liquids. 15 number. Cooking of altitude required more time due to low atmospheric pressure. Okay. Option C is correct. It is present in your book and boiling points. Okay. Boiling point topic, it is present. You should read there. Next one. Wristwatch, calculators, laptops and mobile phones make use of the liquid crystal for the display. Liquid crystals are used in the display of wristwatch, calculator, etc. Okay. Next one. Cohesion in molten electrolytes is due to. Now we know that electrolytes are mostly ionic compound. Okay. Mostly they are ionic compound. So it means when they are molten, it means that their cohesion forces will be due to ionic bond. Okay. Option C is correct. The instrument used for the measurement of surface tension of a liquid is called surface tension. We use stalagmometer. Okay. And this one are used for this one is used for viscosity and this one is used for the vapor pressure. These two are used for the vapor pressure. Now a toy boat is shown in the figure. It floats on water. A small pellet of soap is fixed at the back of the boat so that it dips into water. The boat will move in which direction? So here is a small toy boat and a soap is fixed here. Okay. So they have asked that in which direction the boat will move. It will whether move in that direction or in backward direction. So the correct answer is it will move in the direction of A. How? Let's see. Now we know that what is the purpose of soap. Soap weakens the intermolecular forces of the water and in turn it weakens the surface tension. Now look at here. It's the molecules of water like this. It's the molecules of water. Okay, like this. These are the molecules of water and this one is the surface molecules and these molecules exert force on the above molecule in order to make the surface tension. Okay, due to these intermolecular forces the surface tension is made here. Now when we add the soap, when we fix the soap on a board, it means that soap weakens these intermolecular forces, okay, and in turn this surface tension is weakened. When these intermolecular forces are broken or weakened, then what will happen? The molecule will move away from each other. Here the molecules will move away from each other, okay, like this. When the molecule move away from each other, then what will happen? In that movement, it also give this movement of molecule give movement to the boat also, okay. So when in this place the molecules start movement from each other, when they move away from each other, so in turn it gives the movement to the boat, okay. So the boat will move in the direction of A. See, it's the soap, and when this soap weakens the intermolecular forces of water molecule, and in turn it weakens the surface tension of water molecule, due to which the water molecule moves away from each other, and this movement also gives movement to the boat, okay, this toy boat in the forward direction, in the direction of A. So option B is correct. Honey contains glucose, fructose along with some other ingredient. It has greater viscosity due to. So honey has greater viscosity because of the irregular shape of the molecules, okay, and the strong intermolecular force. So option C is correct. That's why honey is more viscous, okay. Next one, 22. The increase in the vapor pressure caused by heating a liquid is due to. Now, option A, increase in the intermolecular forces among the liquid molecules. It's wrong. If the intermolecular forces are strong, then the vapor pressure will be less, okay. Option B, increase in the potential energy of the molecule of the vapors. No, it's also cross, okay. Increase in the kinetic energy of the molecule. That one is correct, okay. When the kinetic energy of the molecule increases, it means that it will have a greater energy to escape from the surface of the liquid and it will be converted into the vapor state, okay. So the increase in vapor pressure caused by heating a liquid. When we heat a liquid, it means that we increase the kinetic energy of the molecules. In turn, the vapor pressure is also increases. Option C is correct. 24. Detergents reduce the surface tension of water by breaking up the hydrogen bonding. The reduction of cohesive forces increases the ability of the water molecule to wet a solid surface by. So I told you in the previous MCQ that fixing a soap to a boat means that it reduces the intermolecular force, means the hydrogen bonding in the water, which in turn reduces the cohesive forces, okay, which in turn reduces the surface tension of the water. Now in these MCQs they have said that the reduction of cohesive forces increases when the cohesive forces reduces, okay, when the cohesive force reduces, it means that it increases the ability of water to wet a solid surface. So this property is called adhesion. When the cohesion decreases, it means that the adhesion of water molecule increases, okay. Cohesion decreases and adhesion increases. Next one. Which one among the following is not a method for the measurement of surface tension of a liquid? Now, half-life method is not a method to measure the surface tension of a liquid, okay, and these three are the method for surface tension. Next one. Equal volume of two different liquids A and B were taken, means volume are equal if the strength of intermolecular force of A is 2 times that of B. And if A produced 20 drops of telegometric experiment, then liquid B will produce. Now, they have said that intermolecular forces of A is 2 times, okay, and A produces 20 drops, okay. Now, it means that the intermolecular forces of B will be 1 time, okay, and they have asked that how much drops will be produced by liquid B, okay. So if A intermolecular forces of A is 2 times and it produces 20 drops, then B will produce 40 drops, okay. So option D is correct here. How? Now multiply the 20 by 2, so you will get 20 drops here, okay. B will produce 20 drops. Here look, the intermolecular forces of A is 2 times that of B, so it means that the drops of B will be 2 times that of A, okay, so it will produce 20 drops. Next one. All of the following statements are correct except. Now look at here, all of the viscosity of alcohol is less than that of water. Yes, this one is correct, okay. Viscosity of alcohol is less than that of water. It means that alcohol is volatile as compared to water. Surface tension of glycerol is greater than, it means that we know that glycerol has strong intermolecular forces as compared to water. That's why it is viscous as compared to water. So the surface tension of glycerol is greater than that of water. Next one. In a plastic tube, water is a non-wetting liquid. Non-wetting, what is mean by non-wetting liquid? It means that water do not apply its adhesion forces on the plastic tube, okay. Now look, it's a plastic tube, for example, and when water adhere to the walls of the tube, it means that it is adhesion. But in plastic tube, it do not apply the adhesion forces, so it means that water is non-wetting liquid. Surface tension of ethyl alcohol. Ethyl alcohol is less than diethyl ether. No, this one is correct. All of the following statements are correct except, so the except one is option D. How? Here we know that surface tension of ethyl alcohol is greater as compared to diethyl ether. It means that the intermolecular forces between the ethyl alcohol is greater, and they have said that it has less surface tension. So this one is incorrect statement. The correct one is that surface tension of ethyl alcohol is more than diethyl ether, because ethyl alcohol has strong intermolecular forces as compared to diethyl ether, okay. Next one, the most sensitive liquid towards the temperature are liquid crystal, okay, most sensitive crystals. How? We know that the liquid crystals are the intermediate state between the liquids and the solid. We know that liquids and the crystal. So when we give a little high temperature to the liquid crystal, so it is directly converted into liquids, which means that they are very sensitive toward the temperature, okay, they are very sensitive toward the temperature. Next one, the energy required to increase the surface of liquid by unit area depend on. So look here, it is the definition of surface tension, okay, it is the definition of surface tension. So surface tension is directly proportional to the strength of intermolecular forces, okay, surface tension depends upon the strength of intermolecular forces. So option B is correct. If you like the video, then share it with your friends and subscribe my channel for more MCQs or more tests. Allah Hafiz.